So we'll start a session on properties of triangles. And in this session, we are actually going to look at various properties of triangles, and we'll look at some of the theorems and try to prove those theorems and use those theorems to actually solve certain problems. We'll also look at specific properties of right angle triangles, and that's where we'll look at what we call the Pythagorean theorem, right? And the Pythagorean theorem is something which is very important, and it's going to be used over and over again many times in your future. So we'll also look at Pythagorean theorem and try to see what is Pythagorean theorem. Now, what is a triangle? Now, that's the first question, right? So, what is a triangle? So, what is a triangle? Very simple question, right? Now, I can say it is a polygon with least number of sides, right? So triangle is the polygon with the least number of sides, right? If you look at a triangle, if you look at a rectangle, it's got 4 sides, right? And if you look at then you have the pentagon and the hexagon and the heptagon and the octagon. All these things have more sides than a triangle. So triangle has the least number of sides. So it's a polygon with the least number of sides. Or I can say that a triangle is formed by joining 3 non-collinear points. What does this mean? What does this term non-collinear mean? Non-collinear points. Non-collinear points means the 3 points are not lying on one single line, right? Now, let me try to explain that further. So let us draw a line here. So I'm drawing a line, right? And then I'm considering 3 points. So these are 3 points A, B, and C, and all these 3 points are lying on the same line. So the 3 points A, B, C are collinear in this case. If you look at this diagram, in this case, the A, B, C, the 3 points are collinear. But if the 3 points are not collinear, like let us take an example like this. Now these 3 lines, it's very obvious, these 3 points, it's very obvious they don't lie on the same line, right? So let us call it ABC, right? Now if I make the A and B join, like that, C doesn't lie on it. If I make join C and B, then A doesn't lie on it. And if I make a join A and C, B doesn't lie on it. So which basically means, now in this case you have ABC which are non-collinear. They don't fall on the same line. So a triangle can be formed by joining 3 non-collinear points. So 2 ways of talking about triangles. One is that it's the polygon which is least number of sides, right? And it is formed by joining 3 non-collinear points. Okay, fine, excellent. So with that definition, let me just quickly save this. So just a moment. Okay, so that is basically about the triangle, right? So if you look at a triangle, now let us draw a triangle again, right? And let us see some of the terminologies of the triangle. So I'm drawing a triangle. So here I'm drawing a triangle, right? So this is a triangle, and let me name the points. So A, B, C. Now, so what I can say is it has got three vertices. What are the three vertices? So it has got three vertices, and they are, or the three corners, they are the A, B, C points, right? And they are the vertices of the triangle. It has got three edges. What are three edges? Three edges of the triangle, or you can also say sides. All right, three edges or sides. Sorry. So if you look at three edges or sides, right? They are AB, right? AB, BC, and AC, right? So these are the three edges or three sides of the triangle. So that is the other aspect, right? And it's got three angles, right? It's also got three angles, and they are angle ABC, right? Angle ABC, this is angle ABC, and it's got angle BCA, right? BCA, and you have got angle BAC. So it's got three angles. So it's got three vertices, it has got three edges or three slides, or three sides, and it also has three angles, right? So so the real, so we can say the three sides and three angles are called the six parts of a triangle. Okay, so that is about the triangles and the basic terminologies related to the triangle. So terminologies related to triangles, right? So these are the terminologies related to triangles. Vertices, it's got three vertices, it has got three sides and three angles. Okay, all right. Now let us just quickly save this. D2, save. Okay, now let's clear this and go back. All right, so now I want to actually talk about different types of triangles. There are different types of triangles. Different types of triangles. And first one which I want to talk about is what is called the equilateral triangle. Equilateral triangle. You may have already come across these things, so you just consider as a revision. So what's the equilateral triangle? All sides equal. All sides equal. And when all sides are equal, all angles also will be equal, right? So which is like this, right? So an equilateral triangle is going to be like that. Sorry. So this probably is kind of an equilateral triangle where all sides are equal. This is equal to this is equal to this. So that's an equilateral triangle, right? So all sides equal, right? So that is equilateral triangle. Now let us look at what is it. What is next one? Next one is isosceles triangle, right? So isosceles. Now what about isosceles triangle? Isosceles triangle has two sides equal. right? So it's got two sides equal. So it will be somewhat like this, right? So these two sides are equal. So it's an isosceles triangle. So these two sides are equal. So the in fact, even these two sides are equal, the opposite angles, these two angles also will be equal, right? So that is isosceles triangle. So two sides are equal and two angles are also equal, right? So that is isosceles triangle. Then next is scalene triangle. So scalene triangle is where all sides are unequal. All sides unequal. Right? So if I draw a triangle like this, I'll draw it using lines, right? So this is scalene triangle, right? None of the sides are equal to each other. None of the sides are equal to each other. So that's a scalene triangle. Okay, so equilateral triangle, isosceles triangle, scalene triangle. Now the other way, and what is a perimeter? Perimeter of a triangle? Perimeter of triangle is equal to sum of lengths of three sides of the triangle. Pretty simple, right? So if I have the three sides AB, AC and BC, add AB plus BC plus AC, and that's basically the perimeter. Pretty straightforward, right? Now so this is the types of triangle based on their sides, right? Now I can also classify the types of triangle. I can also say types of triangle based on the angles, right? So types of triangle based on angles, right? Based on angles. So now what are the different types of triangles? So you have acute angle triangles, right? So let me just try to draw acute angle. Acute angle triangles means all the angles are acute, right? So now in this case all the angles are acute. All the angles are less than 90 degree, right? So this is an acute angle triangle. This angle is less than 90 degree, right? This angle is less than 90 degree, this angle is less than 90 degree, and this angle is also less than 90 degree. So this is an acute angle triangle. So all the angles are less than 90 degree, right? So that is basically what acute angle is. So acute angled triangles. All angles are acute. That is less than 90 degree, right? So that is basically what is acute angle triangle. Now I can have an obtuse angle triangle. Obtuse angle triangle means at least one angle is greater than 90 degree, right? So obtuse angle triangle. Before that I can say right angle triangle. So right angle triangle. What is a right angle? 90 degree, right? So one of the angles will be equal to 90 degrees. So that is basically the right angle triangle, right? So if I draw it, it'll be like this, right? So and this angle is 90 degree, right? So that is a right angle triangle. So at least one, not at least, only one can be 90 degree, and there is a reason for that. We'll come to that later. There is a theorem that we learn. Based on that, you will find that a triangle cannot have more than one angle which can be 90 degree, right? So if one angle is 90 degree, other two angles have to be less than 90 degree, and we'll see that theorem. Don't worry. Okay, so that is right angle triangle. Now let us look at the next one, that is obtuse angle triangle. Obtuse angle triangle. So in this, one of the angles will be obtuse. That is greater than 90 degree, right? One of the angles will be obtuse. Like for example, if I draw a triangle like this, now in this angle is obtuse, greater than 90 degrees. So this is an obtuse angle triangle. So you can classify the types of triangles based on the sides, where you've seen equilateral triangle, isosceles triangle, and scalene triangles. And you can also classify the types of triangles in terms of the angles, where you have seen the acute angle triangle, where all the angles are acute. You can have a right angle triangle where one angle is going to be 90 degree, and obtuse angle triangle where one angle is going to be obtuse, which is greater than 90 degree, right? So that is about the types of triangles. Okay, so now let us look at a theorem here, right? Now this theorem is okay. Now there are a few things which I want to talk about. So if you look at the equilateral triangle, since all the sides are equal, all the angles also will be equal, and each angle will be 60 degree, right? And in the case of the isosceles triangle, the angles opposite to the equal sides will be equal, right? And so we'll actually discuss that. Don't worry. So we'll discuss that. And in the case of scalene triangle, no two angles will be equal, right? No two angles will be equal. So I just wanted to quickly talk about this isosceles, equilateral triangle, for example. So let's draw equilateral triangle. So this is an equilateral triangle where all the sides are equal. So all the sides are equal, and so all these angles also will be equal. All these angles are equal, and each angle will be 60 degree. All this is 60 degree, this is 60 degree, and this is 60 degree. So that's about isosceles triangle. Equilateral triangle. So this is for equilateral. In equilateral triangle, all the angles will be equal to each other, and all of them will be 60 degree. Now what about isosceles triangle? So if you look at isosceles triangle, so this is an isosceles triangle where these two sides are equal, right? And if these two sides are equal, the opposite angles will also be equal. What are the opposite angles? This and this. So these two angles will be equal, right? So isosceles, the angles opposite to sides which are equal will also be equal. Right? So that is about the isosceles triangle. So the angles which are opposite to the sides which are equal will also be equal. So that's about isosceles triangle. Now what about scalene triangle? In the case of scalene triangle, let's draw one. Right? So I'm going to draw a scalene triangle. So this is a scalene triangle. Right? Now this is a scalene triangle, but where the sides are not equal to each other, and when the sides are not equal to each other, none of the angles are also not equal to each other. So none of all sides are unequal, all angles are unequal. Right? So that is what it's about scalene triangle. All sides unequal, and all angles also unequal. So this is actually about the equilateral, isosceles, and scalene triangle. Some of the things or points that you can remember, right, about these triangles. Right? So here all angles will be 60 degree. Right? All angles will be 60 degree. So these are some of the things that you have to think about when you look at the equilateral, isosceles, and scalene triangle. Some of the properties of the angles, right, when you consider that. So let us just save as T4 and save. Okay, go back. All right. So now all right. Now let us look at let us try to write a theorem here, right? And what is a theorem? Now this is about this theorem. Theorem is about sum of all angles. Sum of all angles of a triangle. Right? Sum of all angles of a triangle. So that's what this theorem talks about. And what this theorem states is sum of all angles of a triangle will always be 180 degree. Always, the sum of all angles of a triangle will always be 180 degree. Right? And let us try to prove this now. Now how can you prove this? Let us take any arbitrary triangle. Right? So I'm going to draw an arbitrary triangle. So here we have some angle, some arbitrary triangle it is. Right? Now I am not sure about the lengths, angles, any of this. But I still want to prove that the sum of the angles A, B, C. Now what are the sum of the angles? Let us call it as X. Let's call this as Y. Let's call it as Z. So based on this theorem, what we have to prove is X plus Y plus Z is equal to 180 degree. That's what you have to prove. You agree? Now how can I prove that? What I can do is I can draw a line. Right, so let me draw a line. I'm drawing a line. We make this a dotted line. Oops. Control C. Making it a dotted line. Okay, so I just drew a line. Let us call it XY, right? And I drew that line in such a way that XY is drawn parallel parallel to AB. So XY is drawn parallel to AB. Okay, so I drew this XY parallel to AB. Now if XY is parallel to AB, then based on the laws or the rules that you studied about parallel lines, you can say that these two are alternate interior angles, right? So angle ABC, please look at my parallel lines lecture, and in that I've explained all this, so please do look at that, right? Angle ABC and angle BCY are alternate interior angles, right? So they are alternate interior angles, and hence they are equal. So that means if this is Y, this is also Y. And same holds good with angle BAC and angle ACX. So angle BAC and angle ACX are also alternate interior angles. And since they are alternate interior angles, if BAC is X, then ACX also is X. So this is also X. Now we have also studied that the angle, a complete angle on one side of a line is 180 degree, right? So complete angle on one side of a line is 180 degree, right? So complete angle, this is a complete angle, this is a complete angle, and this complete angle is 180 degree, which that is therefore X plus Y plus Z equal to 180 degree. Hence the proof. So this is the proof for this theorem. So you have proved this theorem by using this method. I definitely want you to do this proof yourself so that it actually goes in very well. And then once you understand the proof, you are never ever going to forget about this theorem anytime in your life. I have not forgotten till now, right? So you will also not forget. Alright, fine. So I hope you understood this proof very well. So what I did is I drew a line XY which is just parallel to AB. And then I used alternate interior angles concept and equated the angles. And then I told that the complete angle on one side of a line is 180 degree, and hence X plus Y plus Z should be equal to 180 degree. Perfect. So that's what it is. And so with that, I've proved that sum of all angles of a triangle should always be 180 degree. Okay. Fine, let me just quickly save this, and then we'll go T5, save. Alright, so let's try to do some problems using these concepts, right? So what the first problem I'm going to do is, you got a triangle XYZ. Oops. Got a triangle XYZ, right? Where if angle X is equal to 90 degree, right, angle Y is equal to 36 degree, what is angle Z? Pretty simple, right? Now if assume angle Z is X, so what you can do, what you can say, you can say 90 plus 36 plus X is equal to 180 degree. Simple linear equation, x is equal to 180 minus 126, which will be 54 degree. 54 degree, right? So a very simple problem where you can actually do this, right? So there's another problem, right? Says acute angles of a right angle triangle acute angles of a right angle triangle is in ratio of 2:1. 2:1, right? So what are the angles? So since the ratio of 2:1, if assume that one angle is x, the other angle is 2x, right? If one angle is x, their angle is 2x. Now I'm not going to explain this. I'm sure you have learned this in ratio, right? What it means is that for every one angle, every 1 unit of the first angle, there are 2 units of the other angle. So that means this angle is double this. That's what it means. So assume that this angle is x, then this angle is 2x. So what I can say is x plus 2x plus, it's a right angle triangle, so one angle is 90 for sure. 90 is equal to 180. So what does this mean? Which basically means 3x is equal to 90 and x equal to 30. So what are the angles? So angles are 30 and 60. Of course, so 30 plus 60 is 90, 90 plus 90 is 180. So everything is okay. So angles are 30 and 60. So question 1 and this is question 2. Pretty straightforward, right? Okay, now let me just quickly save this and then go on to the next one. T6 thing. Save. Alright. So that is the that's another interesting problem, right? Okay, so question 3. If one angle of a triangle is equal to the sum of the other two, prove it is a right angled triangle. So if one angle of a triangle is equal to sum of the other two angles, then prove that it is a right angle triangle. Interesting, right? How can you do that? Right? Now, so if one angle of a triangle is equal to sum of the other two angles, okay, so consider one angle of a triangle. Okay. Oh, all right. Okay. So So assume that one specific angle is x, right? So one specific angle is x is equal to the sum of the other two angles, right? Now so the sum of the other two angles, okay, so let us take this stuff, right? So x sum of so here it is like this. So one angle A is equal to A, B, other angle B plus C, right? Angle A is equal to angle B plus C, for sure, correct? Do you agree? In this case, if you look at the triangle, that's why it's going to be, right? Angle A is equal to angle B plus C. Now angle A plus angle B plus angle C is equal to 180 degree. That also is there. That's based on the theorem, right? And angle B plus C is angle A. Angle B plus C is also, so angle A plus angle A is equal to 180. I substituted this with angle A. Why? Because I have this equation based on the first line of the question. So 2 angle A is equal to 180, which means angle A is equal to 90 degree, and we have proved it. We have proved that it is a right angle triangle, right? So pretty straightforward. It is just that this first thing you have to look at and come out with a statement, and that's going to actually help you to solve the problem. All right, let me just save this and go back. Okay. All right, fine. Now let me ask you a question. Can a triangle have two right angles? Can a triangle have two right angles? Is that possible? Is it possible for a triangle to have two right angles? Just a moment. Now, is it possible to have for two triangles have two right angles? It is not. The reason is, assume that two angles are going to be right angles. You already have 90 plus 90, which will give you 180. What about the third angle? It cannot be 0. Third angle cannot be 0, right? So since the third angle cannot be 0, hence false, right? Third angle cannot be 0, so hence this just never can happen. It is simply not possible. Okay, so just now let us get into the next. So there are some few problems where we use this property of sum of all angles is 180, right? So I think we just looked at different types of triangles. and we also looked at some specific characteristics of equilateral, isosceles, and scalene triangles. We also looked at the theorem, where we proved that the sum of the angles of a triangle is going to be 180 degree, and we did some problems. We'll continue the next session. Thank you.